What do you say, YouTube? This is Ben from O-Chem Condensed. In this video, I'm going to be showing you an exam from MIT's open courseware on organic chemistry. This is an introductory exam in organic chemistry, and in a follow-up video, I'm going to be going through detailed solutions to all of these problems. So I've included in the description of this video a link to a PDF for this exam so you can download it and work through the problems on your own time before checking out the solution video that is going to follow this video. Let's go. So this is a 1-hour exam from the spring 2005 course on MIT's open courseware, Organic Chemistry 1. This is the first exam given to organic chemistry students at MIT. And it's only allocated for 1 hour. It's actually quite long. It's 8 pages, about 14 or 15 problems with a bonus question. So I actually encourage you to take as much time as you need on this exam because, yeah, 1 hour is not very long. You'd really have to be well prepared to be able to complete it in that amount of time. And it's not really necessary for demonstrating and understanding. All right, let's take a look. So question 1. What is the pKa of an sp hybridized carbon atom? So this is asking us to some degree for memorized knowledge of pKa's. Question 2, circle the letter of the molecule with the lowest barrier to rotation or ring flip. And part B says box in the letter of the molecule. There's some typos in this. Molecule with the highest barrier to rotation. So this is going to be comparing now energies of rotations for molecules like ethane, propane, or butane with the ring flip of a cyclohexane. Question 3, we're going to be ranking substituents from number 1, highest priority, to the lowest priority. These are following Kohn-Ingold rules, which are rules to establish which substituent is ranked higher when determining R and S stereochemistry. Question 4, if a chiral molecule has an absolute configuration of R, which direction does it rotate the plane of polarized light? This is a really good problem. It's something that people maybe have a misconception about in some cases, so it's a really good problem to really understand this solution. Question 5, enter the pKa value for each acid on the boxes below. And part B says indicate whether the reactants or products will be favored at equilibrium by circling the appropriate set of equilibrium arrows. This is a really good problem. It's really general. I've seen this on exams from many universities. And it does involve the knowledge, the sort of memorized knowledge of pKa's, but I've also seen in a lot of cases, without knowing the pKa, still be able to predict where the equilibrium will lie, knowing a little bit of understanding about how acids are stabilized or how certain molecules are made more acidic than other molecules. So there's 2 parts to this problem. Question 6 is, again, talking about acids and bases and equilibrium. A says provide structures to the boxes to complete the following acid-base proton transfer reactions. And part B, for each set of reactants, draw all the lone pairs of electrons and show the electron movement for each by using curved arrows. Part C says indicate whether the reactants or products will be favored at equilibrium by again circling the appropriate set of equilibrium arrows. So here we have an equilibrium between imine and ammonium, and we'll be drawing then the conjugate bases and acids on the right and determining the equilibrium for this set of 2 problems. Question 7 is going to be ranking these molecules on the order of acidity. These are also good problems to be really driving home the concepts of acids bases. Question 8, mentekephalin, I hope I pronounced that right. An endorphin serves as a natural pain reliever that changes or removes the perception of nerve signals. Label all the functional groups present in mentekephalin. So if you are not that familiar with functional groups, I'm going to be putting out a summary of all the necessary functional groups in organic chemistry in a follow-up video. So take a look at that if you need refreshing. Question 9, name this following molecule. I found naming molecules to be an incredibly boring part of learning organic chemistry and not something that you encounter very much in grad school, but it is something you have to get through in the early stages, in the early courses, so there's really just a set of rules that you need to know These are kind of the easy points when you're writing an exam, or taking an exam, I should say. These are the easy questions you can just nail. If you know the set of rules, these are really good opportunities to get points. Question 10, I'm going to zoom out a little bit to get the whole question. Draw the 4 major resonance contributors for the molecules shown in the first box here. Partially completed structures are provided as a time saver. Do not generate any additional charges other than the negative charge that already exists. Part B says draw all lone pairs of electrons and use arrows to show the movement of electrons within the structure. C, place a check mark in the small boxes of the 3 structures that contribute the most to the resonance hybrid. D, circle all the nucleophilic atoms in the structures at the bottom of the page here. All right, so I'll let you interpret that problem. Problem 11, I'll zoom back in a little bit. Circle the structures that represent a conformation of 2,2-dimethylbutane, that's this molecule, sited along any bond. So we have Newman projections on the right, and you need to determine which of these Newman projections agree with the structure on the left. Part B, complete each of the Newman projections below to show the most stable and least stable conformations of 2,2-dimethylbutane sited along the C2-C3 bond. So again, we need to know Newman projections, and we need to know how to draw this molecule as Newman projections. Part C, maybe I'll try to include a little more of it. Part C, using the above Newman projections, calculate the barrier of rotation of 2,2-dimethylbutane sited along the C2-C3 bond. So this is again a situation where, to be able to completely answer this problem, you actually need to have memorized energies of certain interactions, those being potentially gauche or eclipsed interactions. If you don't have these memorized, I would just encourage you to approach this problem by identifying the key interactions that are relevant. And if you do know this, if you do know the specific numbers, you can add these up and really complete the problem. But it's, I say, enough to really understand this problem by just identifying the key factors. Okay, let's take a look at question 12. Part A says, draw in the substituents on the ring-flipped conformers of each molecules, molecule A and molecule B, to predict which molecule is lower in energy. And part B says, show the Newman projections, that's these, for each ring-flipped conformer, siting along the C5 to C6 and C3 to C2 bonds. Part C asks you to draw the chair conformation that is lower in energy for each molecule. Part D, which of the structures is lower in energy, A or B? And E asks you to explain your choice. All right, question 13. Part A asks you to label each molecule as chiral, achiral meso, and Part B asks you to designate each chirality center as R or S. Question 14, indicate the relationship between these 2 molecules on the left and right, as either enantiomers, diastereomers, or the same molecule. And lastly, we have an extra credit question that's a little bit tricky. I'll zoom in a little bit more. It says, one of the steps in fat biosynthesis is the hydration of crotonate to yield this molecule 3-hydroxybutyrate. The reaction occurs by addition of OH- to the psi-face at C3 here, followed by the protonation at C2 here, also from the psi-face. Part A asks you to label the top face of each alkene carbon atom as Re or Psi. Part B, show the stereochemistry of the product. And C, label C3 as R or S. So this is another naming convention that we need to be able to label prochiral molecules containing alkenes. It will be quite tricky, but I encourage you to at least work out what you think is happening in this reaction, work out the different steps, and to fully be able to answer this, you need to know the definition of what a psi and a re face is. That will be covered in the solutions to this exam. Thank you all for listening. Like I said, the exam PDF will be included in the description of this video. I really encourage you to work through all of the problems on your own before watching my follow-up video where I'll be going through a detailed solution for this entire exam. Thank you all for listening. If you enjoy the content of this video, hit the subscribe button. Thank you for watching.